Dear students, what we are going to see in our embedded system topic is priority based scheduling. So generally any operating system want to execute some task based on the scheduling only. So scheduling is nothing but, so we have to create task in terms of execution time. So if you take any operating system or any real-time system, it has to execute task based on what we actually create as a schedule. So in a schedule, we have to mention very clearly their task and their respective execution time and how long the task which is going to be executed. So at least three essential informations are required in a simple schedule. So based on the schedule only, any process are going to execute a task. So here in this class we are going to see about priority based scheduling. So generally the task will be executed by the processor based on by seeing the priority only. So here we can assign priority based on two different scenarios. So by assigning in terms of priority, and after that we don't have any option to change that particular priority. So that is called actually static priorities. And the next one is dynamic priority. So in the sense we have to assign a priority, and during the execution of time we can have option to change the particular priority value based on the execution or based on the deadline. So based on this scheme, today we are going to have two different approaches in terms of priority based scheduling. The first one is rate monotonic scheduling, and the next one is earliest deadline first scheduling. Let me see one by one. So the first one is rate monotonic scheduling, as it clearly mentioned earlier. So it is the one of the scheduling scheme where we should apply priority for our task, and the once we assign a priority and we don't have any option to change that particular priority. So once you create a schedule, now the schedule is understood by the processor and it has to execute our task based on by seeing the priority itself. And you can say that this scheduling scheme which always follow fixed priority module. So in this sense, once the priority is assigned, so now the processor is going to see a task, and based on the priority it will execute one by one. And here being as a RMA methodology, we are going to follow some strategies. The very first thing is each and every task in a processor will execute based on the task only. Okay, so you have to execute task one by one and by seeing the priority only, and the context switching times is ignored. So it's nothing but you suppose if any other task is going to execute during the execution of some task, so that particular thing will not be happen here. So based on the priority only it is possible. And the third very important thing is no data dependencies. So it means that we take an example, three process. Okay, so P1, P2, P3, and P1 will execute a task, and after that P2, then P3. And in data dependency processor, P2 always depends upon P1 and P3 always depends upon P2. Let me take this example. So it meant exactly each and every time before P2 is going to execute a task, so it has to see the results for P1. Similarly, P3 will execute based on the results coming from P2. But that is called actually data dependency. But in case of RME based scheduling scheme, no task or no process will wait for other process. So they have to execute task based on the priority, and P1, once the completion of P1, then P2, then P3, and or it may be P2, P1, P3. So the order will be differ based on the priority. Okay. And the fourth very important thing is we have to calculate the deadline also. So the deadlines always executed at the end of your time period. And finally, very important thing, the highest priority. A process or a task which is having highest priority, that will execute as first one. So always how to calculate the highest priority task. So based on the execution time, a process which one have least execution time, that particular task will be assigned as a highest priority, and vice versa. Okay. So the ranking, the priority ranking is assigned based on by seeing the least execution time. So for furthermore analysis regarding RMA, let me take an example. So here we can have example. We can have three process named P1, P2, P3, and their respective execution time will be 1, 2, 3, and their execution period also we can have 4, 6, 12. So here the total amount of execution time will be calculated by checking the LCM between these three different periods. So 4, 6, 12. If you take LCM, you can have the value 12. Okay. So it meant for calculation of the total execution time for the particular CPU, and based on the time execution time, the total execution time, the process will be executed. So the processor will execute all the process within the stipulated time. So the total amount of execution time will be 12 hours. Let me check 12 hours. Okay. So within the 12 hours, we have to complete, or the processor will complete all those three processes. Okay. So based on the RMA scheme, we have to assign highest priority for least execution period. So obviously, among the three processes, P1 which have the execution time will be maybe execution period will be 4, and P2 will be 6, and P3 will be 12. So how to calculate how to assign a priority? So P1 only having the less execution time, so that it takes the highest priority. Then P2 is the second priority, and P3 will be the last priority. That is the lowest one. Okay, so for that only you can assign the time also. So T1, T2 as well as T3. And how to calculate how many number of times the process will be executed by the processor. So the previous example, you can see the table itself. So I can have a P1 process, and the respective execution period will be 4, but the total amount of execution time will be 12. So 12 by 4 equal to 3. So among the 12 hours, among the 12 time period, P1 will be executed by 3 times but 1 unit. Okay. Similarly, we have a process P2, and the total time will be 12. The execution time will be 6. So 12 by 6, 2. So among the total number of time, P2 will be executed by 2 times in terms of 2 units. Similarly, P3 and 12 by 12, obviously 1. So P3 will be executed by only 1 time, but execution units will be 3. Okay, so based on that only, the processor will execute each and every process. So for every 4 time intervals, so it means, so 12 by 4 is 3, so 0 to 4, 4 to 8, 8 to 12, so we have to execute P1, and every 6 time intervals, so P2 will be executed, and every 12 intervals, obviously P3 will be executed. So here, by seeing this graph, you can understand how the process will be executed. Okay, so if we take the same thing here, so in x-axis I can have a time period, because each and every process they can have a respective time period also, execution time period also, and y-axis I can have process. So we can have 3 different processes. So we can have P1, then P2 as well as P3, and their execution time will be different. Okay, so as I told earlier, so P1 will be executed. Okay, so total time will be 12, total time, execution time, and P1 will be 4 periods. So 3 times. So how to make it in the interval? So 0 to 4, 4 to 8, and 8 to 12. Okay, so these 3 intervals purely assigned for P1. So among the total time period, so we have to execute P1 within this interval. So 0 to 4, 4 to 8, 8 to 12 will be execute P1 by how many number of units? 1 units. Okay. So similarly for P2. So P2, that will be 12, total amount of time 12 divided by actual execution period will be 6. So it is 2. So how to make it period? So 0 to 6 and 6 to 12. So 2 time intervals, and the respective execution units will be, P2 will be executed by 2 units. And finally we can have P3. So P3 will be executed by 12 by 12, which is equal to 1. So P3 will be executed within the time period 0 to 12. It will be executed by 3 units. Okay. So now based on the priority, based on their execution time, we can have the 3 different classification. Okay, so P1, P2, P3. So now P1 among the 3 different process, P1 which is having highest priority. Okay, so it is highest priority, and P2 middle priority, and P3 may be lowest priority. Okay, so P1 is after P1, P2 will be executed. After P2, P3 will be executed. Yeah, based on the priority only, we have made it this particular conditions. Okay, so let me start. So now among the 3 priorities, P1 which is having a highest one, so that it will be executed first. So 0 to 4. So I can start from 0. That is the time period. So how many number of units? Only 1 unit. So this is actually P1. Okay, so the condition is satisfied. So 0 to 4, in the time period P1 will be executed. Yeah, the task is completed. So next, after P1, next we have to execute P2. So how P2 will be executed? So P2 will be executed within the time period 0 to 6. Yeah, already we are in the same interval only. Now already we have completed P1. So next will be P2, and how many number of units? 2 units. So you can start from here to here. So it is actually P2. So now P2 is the first interval is executed. So once P2 is completed, next we go for P3. P3 will be executed among the total duration 0 to 12. Okay, only 1 unit. Okay, so only 1 units. But very important thing about 3 units, but very important thing is only 1 time. So now we have option to go P3. So P3 start from here, because already we have completed P2. So next option will be P3. So the very important thing is P3 will be executed by 3 units, but only 1 time. If I extend the 3 units, what will happen? So 3 to 4, 4 to 5, 5 to 6. But once I cross the limit of the time period 4, that is the time period for P1. So I can't extend execution after 4. So only option we have, I can complete P3 within the time period, but I cannot execute 3 units. I can able to do only 1 unit in P3. Still 2 more units available in P3, because 4 is a time period for P1. Okay, so you can't execute over the time period P4. Okay, so next, the time we have reached 4. So 4 is a time period for P1. So once again, you can go for the execution P1. So 4 to 5. So this is P1. Okay. So once P1 is completed, what is the next one? We have to go P2. So P2, when the P2 execution will start? So first task will be executed within 0 to 6. Yeah, already completed. The next will be executed. Next task will be executed at the time period from exactly 6. But still we are in the time period 5. So still we are not entering the next time cycle. Okay, so still we are in the first phase only. So this particular 5 to 6 time period we can allocate for some other process. P1 already executed. So we can go for P3. So P3 still 2 more units pending. Okay, so 5 to 6 I can use for P3. So once P3 is completed, so obviously still 1 more units there. Okay, so still 1 more units available in P3. So when I enter at the time period 6, that is the time period for P2. Okay, so what is the time period for P2? The execution time period will be, second phase will start exactly at 6 to 12. So I can use this particular interval for execution of P2. So I can extend 6 to 8. So that is P2. Okay, so I can use this particular interval 6 to 8 for P2. Yeah, P2 completely executed, because 2 times you have to execute. So 2 times already, 1 time is available 1 to 3, and the next will be the last one 6 to 8. So when I enter the time period 8, so that is the time period for the execution for P1. So how many number of units? Only 1 unit. So once again, how to execute 8 to 9, that is for P1. Now P1 completely executed. So already 0 to 4, yeah, it's available. 4 to 8, yeah, P1 is available. Then 8 to 12, yeah, it's available. So P1 completely executed. What about P2? 0 to 6, there is a P2. So 0 to 6, yeah, P2 is there. Then 6 to 12, P2. Okay, so 6 to 12, exactly, yeah, P2 is here. And what about P3? So in P3, total amount of time is 12. Within the 12 period of time, we have to execute 3 units. So already here 1 units. Here also 1 units. So still 1 more units I have to execute in P3. That will be executed in the last time cycle. So it is P3, the time period 9 to 10. So now, so the total amount of time what we have calculated is 12. Okay, so we have done our execution within the period of 0 to 10. Okay, so the CPU will execute our task very efficient manner, because so we have a certain limitation for the task execution for a particular processor. So we execute every task whatever we have made as a schedule, that will be executed within the respective time interval itself. And one more thing, this processor will execute our task in a very effective manner, because within the time period the processor completed all the task execution. So the efficiency will be very high, and the CPU utilization also will be very, very high. So because still 1 more time units are there, but even though the time units is there, but the processor completed its execution. Okay. So this is one example regarding the how the RMA execute the respective task. So let me take another one example. Okay, so here we have an example, again 3 process and their execution time and the respective period. Once again we have to calculate based on the process execution time as well as period. So total amount of time will be 12. Once again I have to take LCM 4, 6, 12. So obviously this will be 12. So 12 by 4, 3 units, 12 by 6, 2 units, 12 by 12, 1 units. So now I calculate with respect to amount of time. So the total amount of time will be executed 3 into 2, 6, 2 into 3, 6, again 1 into 3, 3. So totally I can have 15 minutes. Okay, so 15 minutes, but I can have the execution time only 12. So it is not possible to execute the given task. So the processor failed to execute this particular task. Okay, so the CPU utilization will be very, very less, because the total amount of time will be very less compared to the number of execution. So obviously we can't execute or we can't complete within the respective time. Okay. So next one is earliest deadline first scheduling. So this is about the same way we have to assign a priority for our process. But this time the processor execute the task based on by seeing the deadline. Okay. So a deadline is nothing but each and every processor, they have to execute task within the given time interval itself. Suppose a processor failed to execute a task within the deadline, simply the processor failed to execute the given process. So each and every time we have to assign a priority based on the deadline only. So how to find deadline? So a processor which is having earliest deadline, so that processor we can assign highest priority, and a processor having the highest deadline value, that particular process will be assigned by lowest priority. Okay. Okay, thank you. So regarding EDF, let me discuss the next class.